All right, everybody, here's part three of the Standing Waves on Strings series of lectures or instructional videos. Remember, in the first two parts, let me get over here for a second, we talked about the first harmonic standing wave, the lowest frequency standing wave that you can create on a string of any given length, F in this particular case. All right. We talked about how to label that first harmonic, F1, the first frequency, the fundamental frequency, the lowest frequency standing wave, how its wavelength was 2L or 2L over 1, if you want to see the patterns a little better, and how it was 1/2 of a wave. The first harmonic had exactly 1/2 of a wave. Remember, there are only particular frequencies that work. For this first lowest frequency, it's exactly 1/2 a wave on the string of length L. All right. The second harmonic, which was our second video, which we saw last time, F2, the second highest frequency, or the next higher frequency, we saw that it was a full wave, right? You get a full wave, a full standing wave on that string of length L, which means you have two half waves, one wave or two half waves. The first harmonic was 1/2 wave. The second harmonic is two half waves. I think you can imagine what the third harmonic is going to be. We'll get there in a minute. And the wavelength then is L, or 2L over 2. L, if you can, cancel fractions. 2L over 2 if you want to see the patterns. 2L over 2 compared to 2L over 1 for the first harmonic. Because the wavelength is exactly half what the wavelength is up here, the frequency is exactly twice as much, because frequency and wavelength are inversely related. And musically, what we know is that when you double the frequency, you go up an octave. So if this is middle C, if this is middle C, this is an octave above. This is the C above middle C, for instance. Okay, so let's go to the third harmonic standing wave. First thing we want to do is we want to talk about what it looks like. And remember the pattern for what these look like. The first harmonic had one antinode and two nodes. The second harmonic had two antinodes and three nodes. So the third harmonic is going to have three antinodes and four nodes. So what does that look like? Well, I've been doing this a while, so I have little tricks to help me. I'm going to put a little dot here and a little dot there, and then I'm just going to go like this. Okay, there we go. Can you see that? I can barely see that. It's a little glary. But what we have here is we have a node. I'll just put an N, an antinode A, a node N, an antinode A, a node N, an antinode A, and a node N. Now remember, those antinodes are antinodes because they have maximum displacement, right? They're wiggling the most. The nodes aren't moving at all. They're staying in place. The antinodes are moving the most. So really, this string could also be vibrating, right, the opposite of that, okay? And the important point is that two parts that are next to each other, two antinodes that are next to each other, are always opposite. So if this one's up, this one's down. If this one's up, this one's down. And then vice versa over here too, okay? So that's how they vibrate. That's how they oscillate in a standing wave. All right. Now, let's talk about the patterns, okay? So how much of a wave do we have here? Well, if you watched that video last week from Khan Academy, they talked about this, right? This is 1.5 waves. A full wave is to here, and then this is another half wave. Another way to think about it is every antinode is a half a wave. The first harmonic was just one antinode, which was 1/2 of a wave. The second was two antinodes, which was 2/2 of a waves. The third is three antinodes, which is exactly 3/2 of a wave. Or 1.5 waves. Sure, 1.5. We know it's 1.5 or 3/2 because we want to follow the patterns, folks. 1/2, 2/2, 3/2. How many waves is the 23rd harmonic gonna have? Don't try and draw it. Think of the pattern. How many waves is the 23rd harmonic going to have? The first harmonic has 1/2 wave. The second harmonic has 2/2 waves. The third has 3/2 waves. Now, I don't have that many fingers, but I think you can figure by now that the 23rd harmonic has 23 half waves, or 11.5 waves. No matter what harmonic you're on, it's that many half waves. 5 half waves, 6 half waves, 12 half waves. Whichever harmonic you're on, it's that many half waves. That's the pattern. Okay? I expect you to know that pattern. All right. Now, if it's 3 half waves, what's the wavelength? Or what's the length of a full wave, right? Now, there are two ways we can do this. One, we can look at the diagram. And you can see if you look at the diagram, if you start here, a full wave goes up, back to the middle, down, back to the middle. It stops there. A full wave goes to right here. So from here to here. Now, how much of the string is that? Well, if you take a look at it, these 3 antinodes split the string up into 3 equal pieces. So this full wave is exactly 2/3 of the way along. So the wavelength is 2/3 L. Or we can follow the pattern because that's what scientists do. They follow patterns. So yeah, you can see that it's 2/3 of the length of the string, but you can also follow the pattern. The first harmonic is 2L over 1. The second harmonic is 2L over 2. So the third harmonic is 2L over 3. It's not just because it looks right that that's 2/3 of the length of the string. It's because of the pattern of standing waves and harmonics. And this is what makes physics and music so beautiful, because there's patterns. All right. 2L over 3 is the wavelength. What's the wavelength of the 23rd harmonic? Don't trot. Think of the pattern. The first is 2L over 1. The second is 2L over 2. The third is 2L over 3. The 23rd is 2L over 23. Right. 2/23 L. I would never expect you to draw that. I would expect you to understand the pattern and to be able to think through the pattern. All right, so this is 2/3 L, it's 3 half waves, it's F3. Now, what is the frequency relationship? Well, a couple ways you can think about it. The first harmonic, 2L over 1. The second harmonic is half the length of the first, so it's twice the frequency. The third harmonic is 1/3, 2L over 1 compared to 2L over 3. That's 1/3 the wavelength of the first harmonic. If it's 1/3 the wavelength, and according to the wave equation, frequency and wavelength are inversely proportional. If the third harmonic is 1/3 the wavelength, it must be, you got it, 3 times the frequency. 3 times the frequency. The first harmonic is the fundamental frequency. That's the lowest, F1. The second harmonic, F2, is exactly twice that fundamental frequency because it's exactly half the wavelength. The third harmonic is exactly 3 times the fundamental frequency because the wavelength is exactly 1/3 the wavelength of the first harmonic standing wave. Now, some of you are probably thinking, especially the musicians, well, what's the musical relationship, Mr. Morgan? It's not an octave because you said last time that in order to get another octave, you got to double. So 2F1 is twice F1, of course. That's how 2F1 is twice F1. But 3F1 is not twice 2F1. That'd be 4F1 to double it again. To get another octave, you have to go. So it can't be another octave. So what is it musically? Well, if we were in class and I had a bigger board, I'd show you why this is. And this really won't mean a whole lot to people who aren't more musical. But if you are musical, this frequency is exactly 1 octave and a fifth. Now, that's not a fifth of an octave. It's a musical fifth. And again, that probably doesn't mean a lot to those of you who have never had to practice scales. But if you've had to practice scales, you probably know what a musical fifth is. I'll give you a couple of examples. If you are in the key of C major, the musical fifth is G. If you are in the key of G major, the musical fifth is D. Okay? The musical fifth is the fifth note along in the scale. And that's what this is. And that's why it's so beautiful, or one of the reasons it's so beautiful. Not only are there mathematical patterns, but if you know anything about music, you know that a note and its fifth sound really good together. That's how a lot of harmonies are written. All right, that is enough about the third harmonic. We'll talk more about standing waves and harmonics next week. You'll have some more simulations and some problems to work with, and then we will have a quiz next week. So view these 3 videos as many times as you need to so that you can really understand what's happening and especially the patterns. Great. Have a good day.